Wait. Aloitatteko te nyt?
Ei, voidaan ruveta aloittamaan.
Se tarvitsee mikit.
Yeah, I can do better. Do we have to?
Ja muut.
Joo. Kuulutaanko me? Yes.
Joo.
Sitten katsotaan, toimiiks vielä tääkin. Wow. Uskomatonta.
Oh, well done. What time is it? 16 past. You're late. Sorry,
Next time will be
Sorry,
better.
guys. Yeah. So, welcome to Global Azure Bootcamp Helsinki, organized by Finland Azure User Group. It's great to have you guys here. This is Karl.
This is Sakari.
Here we are. This is the Wi-Fi. Do you have Wi-Fi? Azure guest, password roar with Azure. Let's have a small break there, so you guys
And
can
hello
take it.
to everybody on the live stream as well. This is our password to the Wi-Fi.
Exactly. If you are very near, you can use it. No worries.
Yeah, take it.
All right, guys.
Yes.
So, you can start with the lotions.
Lotions, exactly. We have 305 locations worldwide this year of Global Azure Bootcamp locations. Different events organized by different people, everything organized by community, not Microsoft, not kind of any official corporation. This is just, Azure user groups around the world organizing events that just happen to collide in this 24-hour period during the same day. We actually have already started and even finished some of those locations in New Zealand because they start the kind of first wave over there, and the last locations will be ending actually tomorrow Finnish time, which will be like Seattle and some of those other US locations. This is 7th time that Global Azure is organized at all, and we have been organizing that here in Helsinki or Helsinki/Espoo.
4 times, I think.
All of those 7 times altogether.
Yeah, but Finland Azure User Group didn't exist
Didn't
on the
exist.
first times.
Yes,
Yeah.
exactly.
Yeah.
So even before Finland Azure User Group, we have had some community events, some community organizing these Global Azure events in Helsinki, Finland. You can see our amazing Global Windows Azure kind of statue / Scott Q's signature and all of that over there as well. The official hashtag is Global Azure. Please use that. Let's show those people in every other location, and also specifically because this year the first time we have also some other locations in Finland. So in Turku and actually even in Oulu we have kind of extra locations in Finland. So all three of us are actually the most northern locations of Global Azure. So we are just kind of, previously we had only the one of those most northern locations. Now we have all three. So that's amazing as a first time as well.
Excellent. So how many of you guys, is this the first time you are in Finland as a user group meeting? So a couple of you, actually
awesome.
Quite many of you.
Yeah.
That's
Nice.
awesome. So you probably saw the meetup thingy where you applied or registered to this event. So please, now that you joined, notice that we have 10 events yearly related to Azure. So, and they are all held in English. So you are welcome to join all of them. The next one is in June, I think.
Yeah. Beginning of
And
June.
yeah. So then we'll have this regular one in the evening from 4:30 to 7:30 or so about.
During the weekday.
Exactly. So welcome to the community. Today, this is the agenda. This is what we'll be having. This is now the welcome. Then I'm going to talk a bit about the public preview of Azure Functions Premium. Then we'll have Timo over there. He's going to come and talk about containers. Then we have some lunch that is sponsored by Microsoft. Thank you, Microsoft. That's awesome. And then we have Managed Service Identity by Joonas. That's the quick swap. It was supposed to be Tapanila Teemu, but he got sick. So now Joonas is quickly cobbling something up together for you guys. So don't judge him harshly. And then we have the labs, which is of course the thing in Global Azure Bootcamp, given by Karl.
That's right. And we spend roughly 2.5 hours on those labs. We all get to do the Global Science Lab that we are going to introduce very briefly during this welcome part as well. And we all get to have a choice of different labs that we have provided. We have all Azure accounts have been provided, all instructions have been provided for you. So you get to choose based on your own interest and background in Azure, what do you want to play around with.
Excellent.
All right, and the global part of Global Azure is driven by community. There are 8 of us who are organizing the kind of global part, providing all of the communications and all of the swag and all of those Azure passes, all of that. And we have a ton of sponsorship that give out different prizes. We are going to raffle some prizes up from at the end of this day from these sponsors, and of course Microsoft being the kind of, from the monetary point of view, the biggest sponsor with those passes and with lunch. Here, specifically here in the Helsinki event, we also get local sponsorship from local Microsoft. We get the live stream to kind of share this kind of joy around, and yeah, so big hand to all of our sponsors.
Yeah, that is awesome.
Yeah.
And about the 8 people who organize this globally, Karl is one of those people, so that's pretty amazing as well.
Yeah. Oh,
so
we had an extra.
Oh yeah.
Yeah.
And then it's again thanks to Microsoft and thank you to us. Fast swap to video.
So the big thing that we are going to do, one lab that everyone is going to participate is going to do this Global Science Lab. That's a wrong link.
Is this?
Yes. So let me.
Cool. You go.
Some elevator music, and you're not even going to see that we are going to swap
No,
this.
nothing's
up.
happening here.
Be careful with your YouTube videos.
Oh yeah.
Global Science Lab. So how many of you are familiar with Azure? Cool. How many of you have something in production in Azure? Cool. How many of you don't, you're just newcomers to Azure, but you think that you might use it professionally within the next 2 years? Cool. How many of you are here just for your own interest and there's no professional thingy or nothing coming up? Nice. Welcome. All kinds of people. So yeah, I'm not sure if my talk is very good when we're thinking of introductory people, but I guess I'll.
How is this playing? How is this playing? Tell me.
It stopped?
It stopped.
It's my machine. It's very slow. It's the slowest machine in the company.
Autoplay apparently.
Have you ever wanted to discover a planet? How about discovering a planet around another star? excited about the lab this year and have once again teamed up with the Institute of Astrophysics of the Canary Islands in Tenerife to bring you something really interesting.
The research field of exoplanets is one of the fastest developing areas in modern astrophysics. Over the past 25 years, we've discovered more than 4,000 new worlds around stars other than the Sun. And we do that by means of detecting the reflex motion that these planets cause on the parent star, or by detecting the periodic dimming that they cause when transiting in front of the star by blocking some of the stellar light. Finding new planets via transit detection is nowadays the major source of new planet discoveries. Past dedicated missions, such as Karl Ots or Kepler space missions, have provided us with strong statistics on the occurrence of planets and the diverse population that they present to us. We know now, for example, that on average there's more than one planet per star, and that small stars, which are the most abundant in our galaxy, tend to have several planets of rocky nature, like our own Earth.
Planetary transits offer another advantage. These planets provide a very favorable setup for characterization of the planetary atmosphere, explaining the fact that part of the stellar light crosses the planetary atmosphere on its path to the Earth. The chemical composition of that atmosphere is imprinted in the stellar light in form of atomic and molecular absorption features. This has led to the detection of several species in the atmosphere of red giant planets and opened the door for conducting similar studies for Earth-like planets in the near future. These missions were united to relatively small regions of the sky. Currently, NASA's TESS mission is performing a survey of the whole sky in search for transits. The primary goal is to find planets around the brightest and closest star to the Earth in order to provide the best candidates for in-depth study of their physical properties, including atmospheric characterization and, in the future, the search for possible signs of life or biomarkers.
In this science lab, we are going to systematically analyze the new TESS data, searching for new planets discoveries in millions of stellar light curves. We aim to discover and classify, using machine learning algorithms, not only new planets candidates, but also families of new phenomena, such as disintegrating planets, binary stars, and all sorts of possible unique objects that are waiting to be discovered in this treasure database.
We will have the usual point scoring and dashboard system, so you or your location can compete with others around the world. Don't miss the opportunity of taking part on this big day and come and discover a new planet.
Excellent. So, Global Science Lab this year is about finding new planets, right? Awesome. So we have I think it's like over 5 terabytes set of data from NASA, from that TESS satellite. Essentially, just a big hopping, optic lens. Oh. So this is your next recommendation.
Programming in Visual Basic. Oh, I pressed play. No, it happens.
This happens.
I'm more familiar with TikTok than YouTube.
I've heard. So the lab is very easy for us to set up. Actually, globally for the global team part, we actually have a kind of centralized place already kind of running. Essentially, for us as part of the lab, we are actually just provisioning these kind of worker nodes that will kind of are instrumented from this centralized perspective, and it's essentially just as easy as kind of just deploying that particular kind of pre-built image in our Azure passes, and there will be this nice dashboard where we can compete with other locations, but mainly compete with the Finnish locations and obviously win them as well. And we are going to show the dashboard and all of that after the sessions as well. So with that, let's get started with the first of 3 sessions. Mm-hmm. And Sakke, the floor is yours.
Oh, thank you. Awesome. So I figured that I would do some extra stuff because it seems that there's a lot of people, or half of people here, who aren't really familiar with Azure as such. So I hope that the experts in the room will forgive me for maybe drawing some introductory stuff, because if I dive straight into Azure Functions Premium, then if somebody doesn't know what's Azure Function Consumption or serverless in general, then it doesn't make much sense. So I took this prop here if I need to draw something, because drawing is the best. Let me have some pens here. Let's see. Maybe I don't have to draw anything. It can happen. But I wish I get to draw something. All right, let's see. Where's the old show here? Stopping that. Cool. Still working. Azure Functions Premium. First off, I'm Sakke. I've been coding on .NET since 2001, professionally. Or, yeah, trying to be professional, maybe. I'm a co-host of this Ikkuna Studio podcast. Unfortunately, that's in Finnish, but we have an episode every 3 weeks. I'm the founder of Finland Azure User Group some years back. And then our biggest event in Finland Azure User Group is IgluConf. That's in English, so please join us. It's at the end of January, usually. And then I'm the founder and CEO of this company here, Azure. The co-founder, our CTO co-founded this with me. Azure is a company with 35 people, starting next week, 32 experts. The average experience of people is 14 years. We only do Azure and only platform as a service. So if you guys have some VM issues or infrastructure as a service issues, you can come and ask me, but I probably don't know the answer. So I'm not really very good with that stuff. Our customer satisfaction last month was 4.5 out of 5. There are 4 Azure MVPs in Finland, and our company has 3 of those. And in Great Place to Work, we were 6th last year. So premium plan features. Why would you go Azure Functions Premium? And then the rest is demo. Most of the set today will be demo. I'll try to compare the consumption plan and premium plan inside Azure Functions. And this is, for most of this or half of this room, this is interesting because premium plans are something that just came out. So, and it's in public preview, meaning that it's not really supported by Microsoft yet. So not many of us have used it in production. I hope that none of us have used it in production, but we haven't. But it's interesting to know what are the new tools. But before we go into premium plan features, it would be nice to know how many of you are familiar with Azure Function, or let's put it the other way, how many of you are not familiar with Azure Functions? Excellent. So let's talk about Azure Functions, I guess. So this is now we are in uncharted territory. But Azure Functions, how many of you are not familiar with serverless? What does serverless mean? Okay. So basically, first about serverless. Serverless doesn't mean that there are no servers. There's always hardware. It just means that in the cloud, usually when you compute something, you do some kind of payload, some kind of processing, you choose the size of host. How big is the computer you are running on? How powerful is the processor and stuff? And in serverless world, you don't choose this host. You don't pay for it all the time. Instead, you push your payload, your computational need somewhere, and there is some logic somewhere that runs it, and once it's done, then it's done and doesn't cost you anymore. So serverless basically means that you pay for it while it's running, and otherwise you don't. And Azure Functions are the Microsoft Azure's one of their serverless products, and I would say that it's one of the key products. There are some others like Logic apps are serverless and so forth, but Azure Functions are these small pieces of runtime that if you code something on your laptop, that's your laptop, and you code something with Java or .NET or PHP or something, you can push that code into this Azure function, and then this Azure function is something that if it gets, for example, an HTTP request, it gets it, and then it runs your code once. You have your looping and stuff there. It does whatever. Maybe it stores the answer result to the database, or maybe it sends that into some kind of message queue like service bus or event queue or something, and once it's done that, then it kind of dies. So it's a small container, a small code package that lives for just long enough to implement your code. So that is an Azure function, and that is what serverless in this instance means. And Azure functions in Azure traditionally are under so-called consumption plan, meaning that when there's one Azure function running with code inside it or some implementation going on, it might be triggered, scheduled as well. So it could be run every hour or something, so it can be started not just by HB triggers but some other means as well. But when it's running, it's consuming. And consumption plan means that, you know, whenever you run it, it costs you something, some pennies, some cents, and then when it's done, it's done. So that's consumption. And now today, we are going to talk about premium, which is a more robust, more fixed price offering where you actually choose the host. So then is it still serverless? I don't know. We can talk about that as well. But it's a more robust offering of an Azure function. Otherwise, it's pretty much the same when you think of the development experience, of the developer experience. But I'm going to show you demos. I have these performance tests and load balancing tests. Well, not load balancing as much, because we can see the load balancer, but still we have some of these tests where you can compare consumption and premium. So before we go into my talk, why would you use this serverless? What are the cases where you would use Azure functions if you are building something on a platform as a service? So we aren't talking about virtual machines, we are talking about a solution. You want to implement some kind of application, you have a user, you want her to be happy. She's using a mobile phone, mobile application, and this mobile application, maybe you're in a big company, you have API management there to manage all of your APIs. API management routes the request into an API beneath the API management, published by API management, and this API is probably an app service, meaning that it's just like if you're familiar with IIS, you know, the old time, you know, on Apache, it's a web service, and you've decided what is the size of this web server. This app service is a web server that is running your code and API, and it's always on. So in a situation where you need some more computational power for something that is atomic in a sense, that is logically its own, that the boundaries for this task are clearly defined. So you might think that, hey, let's put that code in an Azure function. Let's say that she wants a report of invoices or orders or her paycheck or something for the last month. Generating this report is something that is very clear, right? It has clear boundaries. So you might think that, hey, I want to isolate this logic inside a clear boundary, a runtime, that would be Azure function. So, and maybe also you don't want to have that computation inside the API that responds to all of the requests from your users. If you have here 1 million users and they send a lot of requests to your server, your API server, it will be loaded, right? So you don't want to have here the high computational need for report generation as well, right? You want to put that somewhere else. So maybe you put that in an Azure function. So then she wants report, she clicks a button, there's a request, give me report, better pencils. Give me better pencils. Karl is an Azure function. Not dead yet. What's wrong? There's nothing to compute. Oh, not sure if that's better. No, these are all bad. Anywho, so this API sends a command into service bus or some other queue mechanism where there's a message of, you know, generate me this report, and then we have an Azure function, and we have like hundreds or tens of millions of those, and these guys, they are subscribed into this type of message that says generate me a report, and then one of these catches the report generation and starts generating the report, and once it's generated, maybe stores it in a data lake or blob store or somewhere, and then maybe sends a message here that it's done, and maybe this guy is subscribed to listen and it's done, and maybe there's a WebSocket here that updates this screen automatically that neural report is done or whatever. So yeah, we maybe got a little past the theme, but still. So Azure Functions is something you might use in that for that purpose. So now we have this new thing, premium plan. You guys speak too much, I gotta drink. So what are its features? It has warm instances, and this is one of the biggest things that's been hoped for. Let's go to the drawing board. So when you think of consumption, what is it really? What is it really? There's a data center, right? Microsoft data center where Microsoft has like millions of servers up. There's a server and there's a lot of CPU and something there, and then there's this, there's me, and I want something to be done. There's a request coming in, and my application uses this consumption-based Azure function that, starts when it gets the message. So here would be my Azure function. So what happens if the request goes here and this guy is like full? It has noisy neighbors, right? There's like in this Microsoft data center in Amsterdam, there's like, there's hundreds of thousands of clients, of companies, of applications, of everything running. So the best pen ever. Premium pen. Whoa. So there's a lot of noise here, and you are trying to squeeze in your request here, and they can't give you, Microsoft isn't able to give you this Azure function runtime right then. So maybe they can give it to you in 0.5 seconds, or maybe they can give it to you in 0.1 seconds, in 100 milliseconds or something. But if you are waiting for it on your mobile, and the computation, it's lazy code, it's something that's not core feature in the application. Let's say the computation takes 0.4 seconds or something, and then you add 100 milliseconds because Microsoft is throttling you because of noisy neighbors. They're not able to give you the consumption Azure function, because they can't give you, their resources are full at that time. So this is the consumption plan, right? So now in premium plan, you define this host that only has your Azure functions, and what they can do then is that they will have one Azure function running even if there's no need for it. So this is a big change to the consumption plan already, because consumption plan, it's born when there's request, hopefully fast, but not always. If you put 1 million requests in, some of them won't be fast. So don't rely on your Azure functions being like snappy all the time, okay? So in premium plan, you have the host defined, you will see that later, and then you will have one or more, as you define, of Azure functions running already, just waiting for my request. And what it does, of course, this does that it responds snappily. So if you are using in your application, in your scenario, you need these Azure functions that you are using in the sense that you can't allow them to be a bit slower at any point in time, then premium plan is something you need to evaluate. So that is warm instances. And this has been a big ask from the community, from the developers, because sometimes you want to use serverless, but you want to be certain that it responds rapidly. So warm instances. VNet, virtual network, meaning that, okay, let's continue with this picture. So you have this host here defined. This is your server in premium plan. This is your Azure function premium plan. That's what it's called. And then this is your company on-prem. And there you have your favorite application, SAP. And then you need to move data between your SAP ERP and then your Azure function. So in this scenario, it's impossible, because in that sense that you can't, well, it's possible, of course, if you open firewalls and stuff, but if you need to have this consumption-based Azure function in your internal network so that this guy can see your company network, it's not possible. But this host, this can be added to virtual network that is then shared between your company network and Azure cloud. So there we can create these kind of secure network spaces. Unlimited execution duration. In consumption plan, it's 10 minutes. So if you have a code package you upload here, in this scenario, you upload that in Azure Function, and your code package runs in 8 minutes on your beefy developer machine. You put that in your Azure Function, it ain't gonna run in 8 minutes. It's gonna take a lot more time, and basically that means that it won't work because here the maximum duration for execution is 10 minutes. In premium plan, it is not capped. So it's unlimited the execution duration. In private preview right now, and also probably in production when it comes to when it's generally available, GA, as they say in Azure, when it's GA, meaning that the SLA comes to 4. So that's what you need to wait for if you are building something that you want to have in production and where the business criticality is high enough. You want it to be generally available, so Microsoft provides the SLA, service level agreement, so that it stays up and there's support for it. Anywho, so here it's 30 minutes default, but then it can be, well, infinity is too harsh a promise, but it can be raised to unlimited. Beefier instances. So if you have something on your own laptop, a code that runs in 8 minutes, then you can select your premium plan so that it also is a 4-core or some core with a lot of memory and stuff, so it can be run faster, the thing that you are running. You will see that later with a couple of demos. Then there's high density app allocation, which can be interesting if you work in an environment, if you're working in a corporation or for a corporation or any application where your solution, your application, like this what I drew here, right? This would be one of the simplest applications in the cloud. So if you are creating something serious, you will have a lot of Azure function. You might have like tens of different kinds of stuff. So this high density app application means that once you've created this premium plan, you define this host, then you can have different kind of Azure functions there that are all running inside that plan and all get the benefits that are listed here. So as a demo, here would be the premium plan instance. So for this box, this is a server. I've chosen that this guy is 1-core 3.5 gig machine, and this is my function app that I put there. These are my other 2 function apps that I put there. These are the function instances, right? So this function app, it's running in 6 different instances at the same time, and this guy is in 2 and this guy is in 4, and these are like in some of our applications we've had like 15,000 instances running at the same time. Like if you think of, hey, I have 15,000 files and you want to process all of those parallelly, you just shoot 15,000 instances of Azure functions, for example. And this would be the scaling of the plan instance. So you have the server, the turquoise, Azure, what is that color? Whatever. And inside that you have those function apps, and those function apps scale. So there are multiple of those app instances, and then once Microsoft notices, the fabric underneath Azure notices that, hey, this premium plan instance, this host is full now. It can't accommodate any more of these function instances. It doesn't have the resources. It's coming up the cap. The CPU is over 80%. You can put autoscale on it, and then it can scale more of these instances. So your function instances are scaled with more hosts. So you get more power. And once the day is over, maybe your solution is used during daytime. So once the night comes, all of these black boxes here, there are now 4 machines, right? These 3 machines are downscaled, right, automatically in Azure, and then this 1 machine is still left for you to pay for. So you would have, in this case, in this scenario of premium plan, you would have, even at night, if nobody used your application, you would have 1 instance of all of these, you found function instance of all of these function apps running, meaning that you would pay for this premium plan host. That would be $100 100 euros a month or something like that. So that is high density app allocation, where you are trying to have only one machine and you allocate multiple function apps inside it. Now the question here is this serverless when you are selecting and you're choosing the host size where you're running, when the utopia, the beautiful dream of serverless is that I as a coder, I develop, I build something out of the abstract thoughts that I have. I'm building this cloud castle, and then when I'm happy with it, I'm just pushing it into cloud and it gets an HTTP address or something, and I can go there with a browser or send an HTTP request to API and it just works. And then I get a bill, of course, how much it's been ran. But in this case, you have to think of the resource size, of the instance size. So that's I'm sad about that. But maybe the benefits outweigh the loss there. But it's not true serverless in the sense of what serverless as a word could mean. But of course, technically, true serverless is kind of hard, sir.
Wouldn't that be rather PaaS than SaaS then, if you're choosing the instance size?
Yeah. In my view, these are if you choose the instance or you don't choose, I would go with PaaS as a word to describe both of them. In my view, like if you think of if you think of the cloud in sense, and let's see, what do you have? You have your own VMs and or you have your own hardware, and then you have VMs, and then you have infrastructure as a service. So you buy VMs from cloud, from Amazon or from Azure or wherever, and then you have containers as a service. So you aren't buying VMs, but you are registering containers and runtime and all of that stuff. And then you have platform as a service, which means that platform as a service means, of course, that you have the code and you deploy that somewhere and it runs. And choosing host or not choosing, I don't think that destroys the PaaS. But the next mode would be FaaS, function as a service, which this serverless is closer. So maybe is this closer to PaaS or FaaS? I don't know if you think of that. But then you have SaaS, and SaaS in my mind is like Salesforce or Dynamics or Office 365 or something where business goes out and buys something and then gets the business benefit out of the solution. But of course, if you think of, well, SAP has been mentioned. If you think of Dynamics or SharePoint or any of those things, you can code on top of that, right? You can extend it. So that is PaaS, because if you deploy your own code on top of a SaaS solution, those pieces are PaaS, and you need to take care of those applications by yourself. So in preview, we have restricted duration for now. We have restricted scaling. It doesn't scale because it's in preview. And it's restricted locations. It's not in every Azure location, but it can be found, these premium plans can be found in North and West EU. Yes?
Yeah, so question about the latency there. So how fast this thing reacts? Like, what is the overhead? So I have my code, I put it there, and I address it somehow. So can you give me some numbers, like on latency overhead due to this whole...
I can show you a demo.
Repeat the question.
Oh, repeat the question. So what the question was about the latencies. Yeah. If there's a request, how fast does the Azure function wake up, kind of, and answer?
Yeah, so texture, the latency between client and the function itself, so due to that whatever is in the middle.
Yeah, exactly. You can see that in the demo, but of course latencies are always difficult in a sense that there's the network, there's the internet, and then there's the load balancing. But because premium plan has that one warmed, it tries to have one instance that is not being used currently, just waiting for the next request. It's a lot speedier than consumption plan. But is there some fixed latency, like fixed ping? No, there's some, of course, some differences how fast it responds. But I will show you a live demo of how fast it responds. So I hope that kind of clarifies that. Sir?
That each instance is served, each request is served by only one instance, or that is reused for between the requests?
So the question was if each request goes only to one function app instance, or if it can be, if a request could be shared, or if multiple requests could come into a single instance. Yeah, no. Cool. So, premium instances, right now there are 3 options. So you choose this 210 total ACU. ACU, that's the Azure Compute Unit, I guess, if I remember correctly. And 100 Azure Compute Units is worth a A1 host, which is a very, very puny host. So that doesn't give you much. You gotta try it out. But it's 3.5 gigs of memory, and it costs you 125 euros a month, estimated. And then there's something that's double, 7 gigs of memory, double the compute, and double the price, and then again double. So that's how, if you look at Azure, that's how virtual machines, that's how app service hosts, that's how all of them go, because one regular rack is like 8 cores, and then there are bigger racks with 16 cores or 64 cores or whatever, but one regular rack is 8 cores. So 1 core is the smallest, then they can split it to 2 cores, which is double everything, double memory and double everything, and then the full rack is like 8 cores, but this is 1 core, 2 core, 4 core. So basically this here is not necessarily, but could be half of a hardware server that is in Microsoft data center. Why would you go premium? We spoke about this already a bit, but if you need to run functions continuously, so this means that if you need to run functions continuously, like let's say that you have a global application you work for, or in a place where you have some application that is up in all time zones, right? It's in USA, it's in Australia, and it's used in Europe. So you're getting requests all the time. And let's say you have 100 clients, continuously, meaning that those 100 clients, if they are on a web front end or they are on mobile, they click something every 5 seconds or something. So you get 20 requests from them like every second or something, and you get that all throughout the day. So you will come up, if you calculate how many requests you will get with that, you will come up with millions of requests in a month, like I don't know how many because I haven't calculated my example, which was a great example, but still we are talking like 10 million or more of requests. And at that point, these consumption-based Azure functions will start costing like, over 60 euros, over 80 euros, and so forth, going up. So then you notice that, hey, actually, our application is running everywhere, it's being used 24/7 or 24/5, and these Azure functions are starting to cost something. But these guys are not as beefy as these guys. This guy is like half as powerful. Even the cheapest version, I would say this is like half or more as powerful as this consumption-based Azure function. Meaning that at some point when you pay 100 euros a month for the consumption-based Azure functions, you could buy this with the same money, and you would put half, the same amount more of Azure functions running inside it, because the resources would be enough in that. So at some point, and in general as well, if you look at Azure, and also if you look at other places, Amazon, any cloud provider, pay-as-you-go model, that is something that, of course, is great in the beginning of your solution, because you don't have a lot of usage, right? You will have only a couple of requests. But once you have a large application that is being used by many users all the time, you notice that reserved is cheaper. And that is a fact of cloud life, that consumption-based and pay-as-you-go is good in the beginning, but once your solutions are big, then reserving instances becomes cheaper. Dave?
If you're getting that situation where you have consistent loads,
yeah, Premium is dedicated.
So it's kind of it's just sort of blurring the line. Like
Yeah.
are you chasing more power or still cost savings if you're choosing the premium?
You are getting both. At that point, when you notice that your Azure function cost is 125, and you are using regular Azure functions, if you check it today and you pay 125, I guarantee that if you go premium plan, you will notice that your Azure functions are like twice as fast and still cost the same.
It's quite dramatic still.
Yeah, it is. But it only comes at scale. So basically, when you go to need, so if you need to run functions continuously, start development with the consumption based, it doesn't cost anything and so forth, but once you go to production you can guesstimate the amount of users, evaluate if you should move into premium plan if you know that you're running functions continuously. Higher performance, we already spoke about that. Longer run duration, we spoke about that. If you are using Azure functions and you need to run them for more than 10 minutes, then the consumption plan isn't even an option to you. Other features like virtual network, your client or your company requires that it's in the company network, the Azure function payload, so then you're going to go premium plan. So let's look at the demos.
Can I ask a question?
Sir?
Yeah, about this premium plan, is it also impacting to the scaling up? We have a customer cases where there is a consumer plan,
Yep.
but based on the weather, it can be very burst in couple of hours.
Yeah.
In that case, the scaling up is very slow.
Yeah.
So is this premium plan making quicker?
Scale up. Yeah. So the question was if premium plan scales up faster. So in cloud there are two ways of scaling. There's scale out and scale up. So and scale out means that if there's an Azure function or there's a host, whichever, we just put more of the same size Azure functions or hosts beside it. That's horizontal scaling. That's scaling out. And then the scaling up means that that's usually used with SQL, for example. You have a SQL server in the cloud, and then you notice that, oh my God, our SQL server, it's shit slow. Like it's in the video now. And then you scale up by putting a beefier machine, more cores, more RAM, and all of that stuff. So I have no answer to you. I don't know. Right now, when they're in public preview, the hardware required by their general availability consumption isn't there. There's a lot of noise made by the Azure function team saying that Azure functions run in premium plan should scale very rapidly, just like consumption plan, because consumption plan basically means from Microsoft point of view means that there's hardware, and when there's requests, they actually do scale out and they don't do scale up. So I would, if I was you, I would maybe think of scale outing, because that would be my first guesstimate on how I would start looking at it. But if you really need scale up, I don't know. And on scale out either, I don't know. But they say it's as fast as consumption based. Yeah, between the lines, I think they're trying to claim it's faster than that, but there are no figures. There's nothing. No. And that's, of course, I think that's good in a sense that you aren't noisy neighboring yourself. Because that's something that I haven't liked, because if I have an app service that requires a lot of resources, and then I put Azure functions which can be very spiky and bursty in nature, and they run inside the same host, then they are noisy neighbors with each other. And that's something that this kind of makes clearer. But longer run duration, it's the same in app service as in premium, and virtual network is in app service as it is in premium. So your question is very difficult because you know, I'm embarrassed because I don't know the niggly details where it is really better. But if you read the specs, there's some pointers into how they are trying to say it's better, but they haven't really published anything bigger. All right. About the future though, once premium plans come GA, I would totally move to premium plan instead of app service, just for these reasons we discussed. All right, so let's like, how much do I have time?
5 minutes.
Really?
Yes.
Shit. This is ruined. Can I have more time?
Yes, you can.
Yes! So I probably won't. All right. So where the hell is this? There. So let's look at the so if you're trying to create a Azure function, is there internet? Oh fuck. If you're trying to create an Azure function and you want it to be a premium function, you just select your function app in the creation and create, and then you give it a name and you create a resource group and so forth. And here in hosting plan you go with app service plan, which has been there, like we spoke of app service plans, and then you create new, and then pricing tier. S1 standard is not a premium plan tier, but here in production you can see these three. These three are premium tiers, premium plans. So take one of those. And if you look at the, I don't want to scale too much out, but if you look at the difference, this is an app service plan, this P1 V2, there's included hardware, there's storage and everything. So this guy, there's some difference in the hardware. You can't change the storage or any of that stuff. Okay, so that was the easy bit. Now I have a couple of functions I've created. I've created one consumption and one premium function, and they are similar what they do. And there are two functions. There's HTTP trigger 1 in both of these. This is now the consumption view. And this is so these two tabs. This is consumption, Sakari consumption, this is premium. So, and you don't have to care about this. This loader IO is something that we are going to check out, the loader IO, which is this kind of a load performance tester by SendGrid that I've been using to check out the difference between consumption, how fast they respond, really, what's the real difference between premium and consumption. So this loader IO is just a function I need to create in the root that responds with this code so that loader IO can make sure that this host is owned by me. If you want to replicate this and do something with loader IO or some other you need to verify, then this kind of stuff is easy, but you just have to remember that because there's this in Azure Functions regularly, there's an API URL in the call, let's say this Sakari Premium website. So here, by default, there should be here, between that there should be API. So it should look like that. But the loader IO as a external tool does not check that API folder for their verification text file. So they're checking the root. So I had to go to host.json and change this root prefix. So in Azure Functions, there's a lot of added functionality in host.json you can use to do limitation on run durations and all kinds of limitations on how do you do telemetry, for example. If you send telemetry into application insights in a bundled type or in an aggregate from multiple runs or Azure Functions and so forth. So be aware of that stuff. I don't have time to dive in that deeper, but if someone is wanting to test loader IO after this, I can give you examples of that. So the real beef is this HTTP trigger, and I was thinking of showing you through two examples. So the first example is something where this is when you create an Azure function, this is the built-in code. You get the default code. I just added a thread sleep of 5 seconds there. So that basically means that the CPU does nothing, right? It's just sleeping, the thread is sleeping. So I put that there, saving now. This is the premium function, and this is now the consumption function. Let me saving here, so it's 5 seconds both. Now let's try those out. Now this is the premium. I'm calling the premium function. Not yet. Save, run. Did it crash? Why? Why? Script for function worked. Run it here. Yeah, it took 5 seconds, that's fine. Is my URL here? Oh, it's wrong because I added the goddamn API to show you the API. So now I'm running this, and then I'm running another tab. I'm running the consumption, and you can see from the network that these both take 5 seconds something. 5 seconds, 75 milliseconds to do the other stuff, and this guy was less than 5. That's insane. Did I save that? No, I didn't save that. Save and run.
Just write very efficient code.
Is this? Oh, I'm some kind of an unidentified user. That's awesome. No, really, Azure is secure.
That's why it's not working. Well, apparently we are already breaking some of the services in North and West Europe due to the size.
Oh shit.
So,
well, no, it's okay. I ran these last night, and I have screenshots of the diagrams, but I would like to show this. It's awesome if Global Azure Bootcamp can break Azure. That actually doesn't sound too good. That doesn't sound too robust. Scott Guthrie will be pissed if this happens. Like, these are the kind of shows where there's a lot of people who haven't used Azure, and as an introduction, if you know, it would be awesome. So that's why it's not answering. So this 1.6 seconds is actually the payload demo I want to show later, because the 5 second thread sleep, I can now maybe wait for this for a while, but so the two demos I want to show is the 5 second thread sleep, because that is the same regardless of the CPU, right? It's going to sleep 5 seconds. So if it's consumption or it's the premium, it's going to take 5 seconds and something, right? And the other demo, I have a payload where I'm looking for the prime that is the 60,000th prime. So there's real work there. So, and I'm running the same payload. So then you can see how fast the premium is as opposed to consumption. And if we load it, what is the result of the timeouts and stuff like that when you compare consumption and premium. So that's what I want to show, but I'm not sure if I'm showing that. Meinaatko? Perustabisetti. Jäpä on niin oikeassa. Mulla oli eilen illallakin vähän ongelmia. Consumption. That's something that probably might happen a bit more today though. They always do. Okay. Oh, now it's me. Woohoo! Now save. The ordering is not correct, but that's the last one. So let's look at the consumption Azure function. It should take 5 seconds and something. So 5337. Cool. So now we have these two. So now I have this premium AF thing here, and they are the same tests in consumption and premium. I'm going to put them side by side. So that's not correct. That was just testing. So what I'm doing, I'm getting to 100 clients per second during 30 seconds. So, you know, starting from first second, there are some clients and so forth. So this is the demo that I'm running. And I want to run them side by side. So I want this to be, oh my God, let's see what happens. and these to be there. And so on the left we have premium, on the right we have consumption, and then maybe I can zoom a bit. See? And then I'm just gonna run. Let's check that I'm really doing the same test here on consumption side. Yeah, 0 to 100, maintain 30 seconds, that's correct. So run. Close enough. So this is premium and that's consumption. And this was the 5 seconds thread sleep thingy. Premium reached error threshold, it seems, meaning that it reached 10-second average time. Oh, so consumption is doing better now. That's awesome. Didn't happen in my test. Whoa. Let's see another time what happens. I'm running that another time and both reached the threshold of 5 seconds. I think I ran this without the threshold last time, or maybe not sure. Let's see. Average 5 seconds. So the green bar is client amount. It's growing all the time, as you can see. Clients per second, so request per second. And the average time is the blue one. So now the premium success and the consumption success is a lot better. Premium is executing a lot worse here. This is great findings. I wouldn't buy premium if this was the fact. So let's see what happens when we do the payload thingy. That's interesting. So I'm just gonna, so 60,000 prime. Does it save now? Yes, that is saved. Oh yeah, this guy. Here. Here, prime. So this guy, let's see how long it takes to calculate the prime. So this is the premium that calculates the prime. Wow. Really? Doesn't show the 741, 741 milliseconds, 762 milliseconds, 911 milliseconds. So that's the prime calculation on premium, and on consumption the prime calculation is 1.9 milliseconds, and this is the same code. So this is actually 1.4, 1.8, 1.4. So now we saw that if we look at singular executions, the premium is a lot beefier, a lot faster. But let's see what happens if we get some kind of demo effect when we run the test. So running that test, we just changed the code, so it's the same test. We are running till 100 clients in 30 seconds. Let's see what happens. So now the average time on premium is a bit less than 5 seconds, and consumption reached the error threshold. Premium is still running. Both reached the error threshold, which is pretty interesting because I ran this and neither reached the error threshold. That is awesome. But still, running it again. So what we can see here is that when we have a payload that is mostly waiting, right? So there's no CPU stuff going on, then consumption was pretty good. It's not always, if you run these kind of tests for a while, you notice that especially with consumption, there might be quite a lot of variance how it goes. Sometimes there's threshold because you couldn't get the requisite amount of Azure functions fast enough, and sometimes there's not. With premium, what I noticed when I've been running this for a while is that the throughput is of course more predictable. So if that's important to you, then that's of course something. If there's a lot of waiting, then premium is not that much better. But if there's payload like finding the prime number, then premium is clearly superior. Let's run consumption if there would be a better copy of consumption plan of getting into 100 clients per second in 30 seconds. So that's a quite a lot of calls because every second it sends more clients. So it rises into 100 clients per second in 30 seconds. So maybe my requirements are too rough. But if you are looking now, consumption is doing better. This is the same test we ran 10 seconds ago, and it reached the error threshold of either 10 seconds or timeout 50%. Those are my error requirements, right? So, and in the previous run, it was like 5 successful and 6 timeouts or something. So then it stopped the test because too many calls were timeouted. Now we got 2 clean tests of this type of finding the prime, and this premium average is 3.5 seconds, right? There's 321 successful calls in 30 seconds and 1 timeout. 90 kilobytes of bandwidth sent. So here in consumption we see that average is 8.5 seconds. There's 5-second waiting for your client more on this consumption side. There's 69 successful and timeout at 56. That's like almost half of the requests of this payload went through this consumption plan. Of course, this consumption plan Azure function, because in Azure function you choose the size of your memory in Azure function. This is the lowest amount of memory Azure function, so it is the cheapest one. So there's a difference. Sent 50 kilobytes. So you can see that the performance on this premium side is a lot better. But you gotta remember, this cost me a cent. This is costing me $125 a month. So if you look at the price multiplier, it's like hundreds of times. If you let this run, it's 125, and this is not. This is a lot less. Okay. I think hoping I gave you some ideas and some other stuff on serverless as well. Any questions before we go forward? Awesome. Thank you guys. I don't know what's next. Is it Timo? Timo!
So, yeah, and I have all of 6 minutes, so I think I'll go a bit of a speed mode.
What? No.
According to schedule, yeah, 6 minutes.
Yeah, but sketches are stupid. Stupid sketches. In this office, we don't look at schedule at all. Everything goes better when you forget the time limits.
But it could be more interesting.
Yeah, totally. Menikö mä niin pahasti yli? Enkä mennyt. Hemmetti.
All right, so who is using containers right now in some kind of projects? And who is planning on using containers on a project? Great. Okay, so we have a bit of a mixed audience here. Some are using, some are not. So we'll just start from the very beginning. Should be fine. Oh, everything works out. Perfect. So, a little bit about myself. My name is Timo Kaleva. I'm from a small consulting company called Surfecta. We were established in 2017. We are situated in Helsinki. Currently we have 6 people working, completely staff-owned. Our primary focus is right, and demo effects, if there ever was one. I currently have a blue screen on my laptop, so that's why the screen is frozen. Right. So yeah, just this yeah. So this can actually happen. So beautiful. Right. Right. So what I'm planning on talking about is the different container hosting options in Azure. There are multiple ways you can host your own Docker containers, and I was planning on going through them and talking a bit about why you would want to maybe choose one over the other, or simply how you could get started with it, which would be much easier if I had something to show. But okay, let's start off by listing the first option, container instances, which is basically that is the easiest option, the fastest option to get started, which is, as it might sound like, it's just a hosted instance of a container within Azure. So you don't need to worry about any of the resources or anything like that running there. You select, okay, I want this many cores, I want this much memory running in it, and I want this image to be running with that container. There's one caveat though, you cannot scale. It does not scale at all. So basically once you provision or deploy that container, you are stuck with that until you redeploy. And that is also going to be the similar theme with another container solution we are going to be covering a little bit later. But yeah, that is the first one. Oh, 100% complete. Beautiful. Okay, so the next one. Let's see if I can remember the actual order I was in. Right, the web app for containers. How many of you have used app services or web apps in Azure? Okay, so good. Those are also, I favored web apps a lot. I've used them a lot in the past years because I just love how easy they make to be able to deploy sort of very basic web application, even more complex web application. They give you the ability to get a turnkey authentication, get a course headers, everything. You can get the environment variables set up, everything. So it gives plenty of nice things. And it can also bring that over for your containers. Same thing. So what you can do is once you create the web application or the app service, you can select you want to run it as a Linux-based app service, which will then enable you to select that, okay, instead of me personally manually deploying something code to run over there, I will just point out that, okay, there is my container repository. That is going to be the image I want to run in there, and please just run it. And it will handle the rest. It will go and fetch your image, and it will run and give you all the nice features the app services provide. Let's see if we can get something. There we go. Let's hope we don't have to repeat this too many times. That could be nice. Of course, it's after boot, so everything is slow. It's an old workhorse. Probably should update at some point. Might be a bit faster. All right, finally. So, back to business. So, what we covered so far. All right, so this is actually what I forgot completely, but I figured it might not be that important as most of you had some sort of idea what containers were. But quick recap. So, container, how to say it best? So, well, a set of your application running on a standard set of tools and system libraries that is defined by the base image, which is differentiated from a virtual machine by the notion that virtual machine usually when you deploy a virtual machine, you are dedicating all the hardware of that virtual machine into running your application and all the resources. But in a container, what happens? Let's take out the sounds. In a container, you basically use a virtual machine to run multiple containers because they are using the OS level to separate all these processes, and they all have their dependencies and everything the application needs to run within that container. So it's an isolated environment, so there's not going to be the old school type of DLL hell or similar situation, or something you could run into these days, which with Node, for example. So I think some people might have run into a situation where you have a 6-month-old Node application that simply doesn't work because you happen to run npm install and none of the libraries work at all anymore. So this is handling that kind of issues. So here we have the container instance. And as you can see, it's very easy to get started. So basically all you need to do, you have your subscription, you give it a name, select region, and just select the image. The image is right there, down there. That is fetching the Hello World image directly from the Docker Hub. But you can also use your own private repository if you have such available. So what you get a container instance. It's very bare bones solution, but still what you get access control, you get the ability to stop, restart, delete. It is running at that point. You can see all the CPU usage, you can see the memory, and you can even set alerts. If you happen to be running, the CPU usage is passing certain threshold, you want to get an alert, you can set up alert using Azure's own tooling, which is well supported. You can also use managed identities, but I think Joonas is going to be talking more about those later on. The second option, what if you wanted more? What if that was not enough? So the second one I was talking about is the web application. It's using the app services to run your containers. So this is how it looks like when you go create a new app service. You select a Linux container option, and then you can, as you can see, I cropped out other options, but there were also the options to use Docker Compose, and I believe it was AKS that was also in that same view. But the ability to run single container from either running select samples from Azure or Azure Container Registry, which we will cover later, Docker Hub, or private registry. So if you have some sort of registry available for your current existing images, it's very easy to get them running and see if they happen to work. If everything works, just doesn't take more than that to try it out. And what does it give you? For example, custom domain abilities, integrated CI/CD pipelines, integrated AAD authentication, or more like turnkey authentication. If you have used app services, you've probably seen that the authentication, one of the selections for those app services there, where you can select that, okay, in order for end user to be able to access this application, they will need to be authenticated with one of these identity providers, which is very, very nice. You don't need to, as an application developer, you don't need to worry about that sort of thing at that point. And of course, custom certificates as well. And as well as we covered earlier, most of the functionality provided for regular app services is available for you. Some of them are limited outside, but those are going to be most of the time edge cases, which hopefully you will need. And if you do need, then this is not the solution for you. But okay, so what else is there? So now we covered container instances and web applications. These two are likely to be the easiest way to try out, but we have other options as well. So okay, those were targeted if you want to run some kind of web application, UI. So what about if you want to run some kind of background logic? Now we come to functions. Functions can run Docker containers. The only limitation is that you will need to build your function based on the base image of a Azure function, which is, but that allows you to easily develop it locally before you have to deploy it all the way to Azure. And it's also, if your whole DevOps process is built around containers, then that is a good way to keep everything uniform. Other option, how many of you know Azure Batch? Very few, but great, a few new. So Azure Batch, so if you do not know, it is meant for large-scale CPU-intensive processes. Well, I think the best example I can think of right now would be the rendering and such, which are tasks that can be partitioned into small holes and distributed, for example, to 1,000 VMs running the same thing. Each of those VMs would be performing one part of that calculation or operation, return the data back, and you would be getting the whole picture. And those you can also be using containers to run that logic. So now we get into somewhere more interesting. So the previous parts covered the cases where you are basically running, okay, I'm doing some little development, or I have some old software running somewhere that is containerized, I just need to get it somewhere. But okay, how about when we actually want to do some kind of larger software that we want to develop into a production environment? Then maybe the scale of those is not going to be enough. So that is when we are talking about container orchestration. And that is when we come to talk about lifecycle management concerning provisioning, deployment, scaling, redundancy, monitoring, isolation. And this is basically your way of being able to handle larger collective of the containers in a single I'm losing the train of thought here. In a concise manner, just say like that. And even for this, Azure has multiple ways you can do this. Actually, there were even more, but one of the options has been deprecated this far. So there used to be also Azure Container Services, but that has been deprecated in favor of Azure Kubernetes Services. But first one we will be covering is Service Fabric. How many know Service Fabric? You. So how Service Fabric came to Azure, it's basically providing scalable software service for microservices. You use its either you can, okay, you don't need to use its own programming models, but you could use that to create scalable, resilient software. What it does, it creates a cluster of VMs in the background. You can upload your own software in there, and then you can also set up, just like in any container clusters, you can set up health checks, see if they are running in there, And you can also do resource monitoring. You can see if they need to be scaled up, scaled vertically, horizontally, how much they need resources. Lately, they have added the ability to also run containers in Service Fabric. So that is why I included it. But unless you are actually using it for the application development as well, I really can recommend just for running the containers, because I think AKS is still the superior solution compared to this. But if you are already committed to Service Fabric usage, then it's fine to be using that as well. No problem. Also, I'm not quite sure if this, it wasn't a long time ago since I checked this, but Linux version for Service Fabric is open source. Windows version, not quite so much. I believe that is still a work in progress. There hadn't been a lot of updates lately. And that is the internal tooling Microsoft is currently using to power many of the core services in Azure. And here we have the big boy, AKS. I think if you know something about containers, you have heard about AKS, which is pretty much the de facto orchestration service currently available for Docker containers in general. So what AKS does, it provides you, when talking about AKS, I'm interchanging it with Kubernetes. Kubernetes is the actual de facto standard for managing. AKS is Azure's version of the managed Kubernetes environment. It very neatly integrates to many of the IaaS offerings Azure has, and it has a large community. So there's plenty of information available, plenty of training available. You most likely know someone who is very adept at it. At least they know how to run a local Kubernetes cluster, and they can use that same knowledge to operate a cluster in Azure as well. Because Azure portal allows you to open up a Cloud Shell, which will allow you to use the Kubernetes control shell programs as well. You can also do that locally, but in case of larger installations, you may have isolated the actual cluster from outside web. So you may have only opened up certain pathways from a jump box, for example, which was the case in one of the recent projects we had. They wanted to have very secure environment. So basically what had to happen was that the AKS lived inside its own network, which was accessible from the outside only through a single jump box. Logical isolation, which is basically shorthand in this case for namespaces, allows you to utilize the same cluster. You don't need to have own cluster for every single development team. For example, you can share the same cluster, share the headaches. And dev spaces is also, it's a relatively new feature, but if you are developing for AKS, you definitely should be looking that out. It makes it so much easier to onboard new developers for your project, especially if it's microservices. You have lots of smaller services that need to be running as a container somewhere. So instead of them having to deploy their own environment, then start deploying each container separately. So this makes it much easier. But there's the big caveat. Just as in container instances, you are currently locked to the node size you selected in the beginning when you deploy the AKS environment. And that is very well. And this means that the AKS cluster nodes, not the pods. And this is bad, especially in environments where you can run multiple containers that have very different resource intensiveness. Let's just say it like that. For example, one project we had was where they were supposed to be running in the same cluster Elasticsearch and as well as some smaller microservices, which are two completely are very different in their resource intensiveness. The Elasticsearch, I think the basic requirement was something like 4 gigabytes of memory, at least 2 vCPUs and something, and it was minimum, no actually, sorry, it was 8 gigabytes, and for the microservices, like 1 gigabyte, 1 vCPU. So you have to run all of that in the same nodes. What you can do in AKS though is you can alter which parts use how much resources in which nodes they are running on. So there is some leeway, but that is going to be requiring some manual work. And if you want to, yeah, and also you can add more nodes, but that is still going to have to be a manual work. And as mentioned, Azure also has its own container registry. So if you have some private images, container images, you do not want to share with the world, you can provision yourself Azure Container Registry and upload your images there instead of a Docker Hub, for example, or other self-hosted solution. And this is also supported very well by all the Azure services. So most of them have the option of simply selecting either typing out the Docker Hub image, or you can just start browsing the options available in your container registry, which is located in the same subscription. And those are the majority of the container hosting solutions in Azure. I'm not saying this would be the only ones, because it seems like every few weeks there comes a new service that somehow supports containers in some capacity. But I think these would be covering the most commonly used scenarios. I had something I wanted to show you earlier, but the unfortunate blue screen slightly came in the way. While I open that, does anyone have any questions? So either I've been nobody cares, or it's been completely clear for everyone. So that's good. Just a moment.
I can ask a question if you want.
Sure, go ahead.
Can you give us, if possible, an example of where, in what real-life cases you're using it, like some sort of project or company that it's having this solution? Or
I think in majority, the web app for containers and the container instance, those are run mostly in the development capacity. We haven't done projects where we've done production environment with those, but we have done it with AKS. So AKS so far has been the one we have leaned towards. And currently I am working on one project where we are deploying AKS, which is the one I described with the isolated VNet, and that is currently running about this. That also has Elasticsearch running in it, because that was a project where the company that contracted us, they were migrating in from AWS, and AWS had hosted Elasticsearch, which Azure does not. So what we had to do is we had to containerize the Elasticsearch and have it running in the background as well. And then also what we had to do, create load balancers between all these parts that were in there. They had about 10 custom parts running in their solution as well. So yeah. So yeah, mostly AKS for the actual slightly larger scale production use and large scale production use. You can use the web app for containers for running websites or something, which is mostly limited to one container. But whenever you go, you have a solution that requires multiple containers, I would suggest you use an orchestrator. So But yeah, they're great for developing and testing phases. Okay, let's see what we have here. As I lost everything in the blue screen, I will just quickly show that here I have a web app container demo, which is running on app service. So as you can see, it looks just like the regular app service, with the only change being that there's a few things that are grayed out, extensions, app service editor, which are quite understandable omissions. But if we go here, we can see it actually responds, and that Nginx is running inside the container that is running inside the app service. And what else we had here? There we also have the function, which I mentioned. Same thing. As you can see, the URL changes. This is what I deployed as well. So this is the function that is operating the container, which is also a nice function to have. And as you can see here, everything is read-only because you can't really update the container from here. And here we have container instance. Unfortunately, the AKS, I have it running, but there's nothing really going on in there, so there's not much to see. And this is not running either for some reason. I think this also has something to do with the same thing that Sakari mentioned, that yeah, some issues currently in Azure. Now it's of the opinion that there are no resources available. There are no Linux resources available for some reason in that data center, so that's why it's down, which makes sense. All right. I think, unless somebody wants to see more of these, but I think that's about that covers the most cases. Service Fabric I did not provision because it's a bit beefy installation. I don't have the developer credits in my account enough to run it because it requires something like 3 VMs just to be able to create it. So it eats up all the credits. Yeah.
So I've never used any containers for anything. So I'm just when you're choosing this kind of infrastructure setup, what's the kind of sales point of picking your container environments for a production rather than, for example, VMs or like Azure Search or something like that?
Well, for containers, I think the immutability of the environment or the basic environment running is one of the main selling points. So you don't need to worry about if something changes under the hoods that your application is running. You always know you have this same set every time, and then you simply put your application on top of it. And what you also do is you bundle all the dependencies what it needs. And also what happens once you go into this container focused development cycle within your company, you will also start, if you do things that are in the same field, for example, you may start gaining your own base images. So once you start doing similar projects, which may require perhaps some additions to some base image, then you create a base image of that, and then you have one step forward for the next project as well. And the difference between the VM and the container is that a VM is a heavier solution, and it's only for that application. You can run multiple applications, but inside VM there is no isolation between those processes. So there is a theoretical chance that they could interfere with each other. But
so I guess the thing is, if you're using the containers in a developer environment, like you've got the team of devs, and like you said, you've got your node installations and then VM and all those things that break between different versions of Angular.
Yeah.
But then if you then don't
So in a situation where you develop with a container but don't have containers in production.
Yeah, like you're saying you use them all in development, and I have friends of mine who are saying, yeah, it's great for our developer environments, we can spin up new guys and they have a laptop and a container and they've got our software running.
It makes it easier if you can run the containers in the production. It's not a requirement. What it just means that all the developers will have the same playground to play with once they get it running on the computer. But there's always going to be the risk. Okay, so what is going to be different with the container environment and the production? So that's something you need to solve within the project, but it does give equal playground for all the developers who can trust that it will run on their machine once they get the base image on it.
Quick question. So we usually pay for resources, and apparently when you have application in the container and container inside some kind of orchestration of the system, again, can you tell how much overhead is like resource overhead is on the container and infrastructure side? And do we pay for resources? Probably we are not paying for resources just spent by container. We pay for everything, right? It's used also to run the container. So is it like 10%, 15%? How much?
It's there's not really much that much overhead because it's still running. All of these are running VMs behind the scenes. We could see some of them. Actually, I can just go see here. The container itself doesn't cost anything on top of these, but the base infrastructure that is running here, that is still going to cost the same as it would if you were to run it without the containers. So, for example, let's see if we have the. Let's check the app service. And here we have scale up, scale down, and see we see that we still have that same VM as we would in the normal app service. We just have something else running in it, and the function app, as we had to select the Linux running environment. That means we also had to select the app service plan, which is going to cost some just to exist. So there's no consumption model for function services in this. And the AKS, for example, AKS itself does not cost anything. That's free. But what does cost are the nodes in the cluster. So that is all up to you how much you want to dedicate resources into that cluster, how much it's going to cost.
So basically all the overhead goes to the containerized model. Kind of that you actually choose to run stuff in the container and you need to support the containers in it. Right? So, as opposed to run application directly on the VM.
Well, I'm not quite sure if I understood the question correctly. If you're talking about if it's a heavy process, if it adds a lot of overhead, is that what you're asking?
Yeah, something like that.
Yeah. So no, it's relatively light process in general sense. It doesn't add much. I don't have anything. I wasn't prepared for a question, so I don't have any figures to show you how it would change. But but as with everything else, it's relatively easy to scale unless you use container instances where you can't scale. But what you can do is, if you have the ARM templates, you can simply deploy multiple instances of certain servers, run them with a certain set, load test, and see how much it would cost you. So that's the best way usually to gauge how much something would cost, because it's hard to say for sure that okay, this is going to cost you this much in Azure, as it's mostly based on how much you actually consume. Yeah.
On the demo you showed, did you run the exact same container on the app service and the function apps?
Yes, I ran the Nginx from Docker Hub.
And on the function example, did it run only while it showed the web page, or is it constantly running on the function app?
It's constantly running. It's the app service plan, so it doesn't really change anything. It's in the standby mode. It's not constantly ticking away, but what does consume it is the app service plan itself. Despite if you don't have any requests coming in, you're still going to have to pay for the certain amount if you have the app service plan. All right.
What,
Yeah.
If you think about all the services that are available in Azure, what of those can you wrap into a container, or can you put anything in a container?
Which Azure services you could wrap in a container?
You were talking about you can run, you put your web application and the data storage that it needs, you can put it in a container and manage those as a one single unit. But, well, let's say SQL Server, stuff like that, can you put all of those services into a container as well?
Yes, you can put a SQL Server into a container. It's probably not the it's not the best use case. I probably wouldn't do that if it was an option. Well, in the case I was talking about, actually, that was not an option. We are not running SQL Server. We are running Postgres. But that was because they were adamant about having to having a transferable environment. They didn't want to be tied down to Azure in any capacity. They wanted to be able to lift and shift the environment into another Kubernetes environment somewhere else. So yes, you can run SQL Server, and I think there was even there's a ready-made sample somewhere where you can get an ASP.NET Core and SQL Server container ready to run in one of these. Can't remember which. But yeah. But in the real world, I would still, unless you are actually planning on moving away from Azure, now that you're actually investing all this time and effort, I still prefer mixing in the platform services that are available. For example, in the SQL Server, I would use SQL Azure preferably, but that's just me.
I was just thinking about scenarios where you have a development environment and test environment, even though you have one single instance of your application that you are delivering to a customer, for instance.
Yes, it's perfect.
Then you would wrap all of the, as you were talking earlier about all the dependencies, you would put them in a container, and then you would put it in a test environment, then some staging, and have that exact same application, all the same identical code running in different environments, and then at some point you put it in your production environment.
Yes, that is if that is the wish, you want to be able to have the exact everything running within the containers. Yes, that is completely doable, pretty much. But it's but you can't. These services are not something you can wrap up inside the containers, pretty much. So what you have to do is you need to have a similar service, or for example, with the SQL Server, you need to have the SQL Server separately running, which would be about 2016, I think, at this point.
Yeah, the containers are volatile, aren't they? So I think, I know this is a long time ago, but I read some advice that it was a bad idea to store your data in the container because they can be.
Yes. Yes.
Yeah.
And that is why you don't store any of the data inside the container. That is why you utilize Azure Storage for storing the data.
Same as with app service, you can store data on the local disk, but you shouldn't do that.
Yeah, just you can store, but don't expect it to be there when you need it.
All right.
But if you are really into this kind of heuristic mode that you don't want to lock yourself into any kind of external things, then you can configure your kind of AKS deployment in this kind of stateful set mode that you actually have kind of more than 3 copies of that container, and together they are kind of making sure that they always have them on sync, all of that. So kind of essentially all the work that Microsoft is doing with storage, you could do on your own inside the cluster as well. You should really, you don't get the benefits, but if you really want to keep everything in Kubernetes, that's your way.
Yeah. Usually there's some middle ground you can find where there's simply no sense in doing everything in completely puristic fashion. So, but yeah, in the general sense, don't store anything within the container, always outside. All right, that is all. Then thank you.
three different variations of Subway. Please take just one. And over there we have a vegetarian. Then we have the ham over here in the big box, and then the turkey over here as well. There's a sandwich, some cookies, and please feel free to grab some water or other drink here as well. A quick break to eat actually, and then we'll continue with you on this session.
Development side. Not thinking too much about the
Well, it's automatically set it up to be on. There is functionality where you can do the health check for the posture. You can set the threshold. So if CPU just crosses this threshold, then you should. It should be general available.
It's going. Yeah, I think that was just like that. Yeah.
onneksi toimii kuitenkin. Joo, ei mitään tällaisia. Hyvä, että sulla onnistui kuitenkin tässä. Joo. Mitäs Sakari, se demo siitä, niin ota se sähäykset pois. Kyllä mun mielestä se puhekin on jos on haluaa. Joo, ei tiedä, ei tarvitse liikaa. Joo. Mä pikkasen lyhennän muun muassa niin kuin äskeisen hänellä kaatu koneen ja käynnissä. Joo, se on tommosia pieniä. Joo, sit tommoset vuosia. Muuten nyt tosiaan pieni break ota vaan asiallisesti ihmeessä. Meillä on keskemmäisellä liikkeessä siellä tässä on reikiä. Pidetään pieni break ja sitten jatketaan taas. Ei ole tämmöistä rapinaa. Tosiaan siinä on puolen tunnin se sillä viimeisellä. Sitten on oikeastaan siihen. Mä vedän semmoinen rinköviin siihen loppuun. Se on vaan semmoinen, ei nyt mitä aletaan tekemään. Siihen voi katsoa.
Onko teillä kokemus tuosta, te ette ole servicipalveluita käyttänyt ollenkaan?
Joo, kyllä.
Mutta onko se vähän sellainen, miksi olette sanonut, onko se vähän poistuva tekniikka?
No sehän on, siis sehän on ollut kilpaileva tekniikka nyt käytännössä ja aika selkeästi nähdään nyt, että toi Ube olisi nyt niin ajamassa niissä omien suorituksen puolesta.
Joo, että se on vähän niinku rivien välistä voit lukea, että...
Se on siis, eihän se niinku teknologialla poistuu.
Ei, koska sehän on niinku ydinkoko asuudelle niin, kaikki palvelut rakennettu.
Mut just niinku kolmannen osapuolella se tulee varmaan aika vahvasti olemaan niinku, vahvasti menee niinku, mä näen kyllä menee Kubernetes. Kaikki tuulikin, kaikki menee niinku Kubernetes.
Joo, ja Google panee oma cloudissa kanssa, ja panee kasviekonettiin siihen. Lisäosia tällaisia. Meillä on yksi projekti, mihin me ollaan miettimässä, tai Arkari on miettimässä Service-fabrikin käyttöön. Siis se on niinku puntaroimassa. Se on niin Windows kautta ihminen.
Siis on siinä niinku pros and cons.
Joo.
Tuo Sakki on meillä käyttänyt enemmän, että tiedetään niinku verbi-mielessä ja sitä niinku, mulla on siellä niinku reliable accuracy.
Joo.
Se on niinku tosi jees.
Joo.
Niinku, siinä mielessä niinku firmana business päätöksessä on aika vaikea laittaa niinku sitä. Mieluummin tekis vaikka siis niitä Windows-kohteja sitä AKS.
Niin jopa. Joo. Joo, se on vaan niin, se on niin die hard Windows-kaveri säännössä. Tietysti sä oot käyttää sitä Actor niinku ohjelmointimallia, se on niinku.
Onhan se siis.
Joo.
Se on eihän se tuu kuoleen, varmasti tulee mahdollista. Ei se on niinku managerin sinne.
Joo. Eli tuntuu, että vähän kurkkinut sitä niin Microsoftin passin kauheasti efforttia sen kehitykseen tällä hetkellä.
Ei oo hetkeä taas tullut mitään.
Joo, että sillä on vähän sellaista päivitystä. Sekin on, sehän on puhdasta VM. Niin. Että aika porukalla on sitten sellaisia omaisia intressejä. Miksi näet virtuaalikoneet? Mähän itse virtuaalikoneesta käytä mihinkään ollenkaan. Hyvä siis se hosti pitää päästä ja kaikkea tällaista. Siis mä oon vähän kuullut, että ketkä käyttää paljon asioissa virtuaalikoneita, niin ne on jossakin ollut vähän ongelmia sitten, että se meni jumiin.
Joo, siis lähtee niin kauan kun sä oikeasti muutat sen ohjelman logiikkaa siihen, että pystyt niin hyväksymään sen, että sovellukset tai ne ikään kuin hostit, vaikka ne olisi VMiä, niin ne on ikään kuin kuolevaisia. Samalla kuin kaikki nämä yksittäisen kontin tämmöisen selvyyden.
Monesti sitten ymmärtää sitä, että no tavallaan niin kehittäjän näkökulmasta tietyissä asioissa on helppo ottaa virtuaalikone käyttöön alkaa siellä, kun sä voit NDP:llä ottaa yhteyden. Mutta sitten kaikki tollaiset niin kuin nämä Azuren palvelut niin tuossakin, niin että sä saa niin kuin insightia tai tällaisia. Miten sä monitoroit sitä sitten helposti sun web-sovellusta virtuaalikoneessa? Kato.
Ihan nyt on aika mitä tahansa niin on-premise.
Niin.
Saa mitään piirää hyötyä.
Joo, mutta ainakin nuo isot firmat vielä, niin ne pyörii niin Suomessa nämä vakuutuspankki, alakin on ollut, niin niillä on virtuaalikoneita ja se vaatii sit sitä niinku infrapuolta.
Ja toinen A kalliimpaa, B ei riittävästi omaisesti.
Joo.
Ja se tulee kokemus siitä, että pilvi on kallista ja huonoista.
Ja sitten tuollainen niin kehittämään DevOps flow, niin se on vähän hankala toteuttaa, koska sitten tuollaiset virtuaalikoneella ja tällaisilla. On sekin mahdollista, mutta se vaatii sitten niinku resursseja, mitkä hoitaa.
sitten niin
Joo.
näitä annettiin mahdollisuus itse luoda koneita, niin hoitaa kaiken itse sitten vain. Jos on mitään paita, niin sä oot vastuussa siitä.
Jos sä haluat tuollaisen niin virtuaalikoneen kautta julkaista vaikka palvelun, ja tarvitsen, että jos on jonkun datasentterissä, että sä oot julkaistua sen ulos oikeesti. Se on pitkä prosessi. Niin joo, se ei tule. 10 vuotta sitten haluan julkaista Windows 5-saitin firmaverkkoon. Se oli ihan niin kuin, siellä saa 6 valtion työn. Eri yksiköitä. Kontit on täällä, niin ne tulee oikeasti. Varsinkin jos saa tuollaisen niin samaan VM-nettiin. Ja sä voit ottaa kaikkea muutakin sitten. Niin kuin tavallaan sen niin kuin edistyksen. Mä en tiedä, miten toi on huonoja kokemuksia, kun tässä yhdistetään Azure ja on-premise datacentteri. Siihen ei ole Microsoftilla vielä mitään. Se on useita vaihtoehtoja. Se Express-soitte. Sitten onko se site-to-site VPN? Se on se uudempi. Joo. Okei. Joo. Okei, joo.
Ja siis se agentin duuni on se, että se yhtälee vaan ulospäin, kun verkostoja ei mitään sisällä. Se käy vaan pollaamassa sitä proxyä, ettei olisi tullut jotain uutta. Okei, nyt on hyvä.
Joo.
Ja SSL yli 40 000 teillä on internetin suuntaan.
Niin se on monesti auki, joo. Se Express-route on vähän niin kuin...
Se lähti vähän takaisin meidän lähtemässä. Täysin on niin kuin kokonainen
Joo. Kontit on jees, VMT. Se vaatii vähän erilaisen pajattelun.
Mitä ne meidän siinä on käynnistää?
Joo.
Jos se hetki on mitä siinä on päässä? Voi miettiä sitä, että nyt on mielessä, että sen rakenteellinen olemassa on joo.
Joo. Mutta se on paljon kevyempi prosessi kuin virtuaalikoneiden päivitys tällaista. Niin. Joo.
Azure Friday is you just go Friday and there's a so at least every Friday they have new videos from different Azure topics. So he's funny and informative. He has different faces talking on the different products. So it's like 10 to 15 videos things that can kind of subscribe to that. Yeah. Anything about it, you have a lot of You go in this and realize that you'll be there, just take it as it comes, you know. It's like, I didn't think it was an adventure to the cloud. I did that with Karl. He said it was great. All my friends together, I thought, we just keep him and keep going. So this guy went like driving up to the
So it doesn't matter which way you are. What is the kind of master of your data? So if you create new kind of you can definitely configure it both ways.
Yeah, exactly.
The master is all the typically you don't mix them, you only have one of them, so you don't create both in the cloud and on premises and consume those. That's not what you use.
2 months?
You select one of them.
Document and they're saying it's only one way.
What would be my I personally I don't want to have that anyway, so like what would be my case if I'm already on the cloud, why would I need that?
No, my father's passed away, so he was there.
So why didn't you try like automatically have an actual Azure AD on top of the virtual machine running on your Azure as well? So if the connectivity is an issue, you can have kind of part of your domain workload. Now the AD replicas for each cloud, you need to just have Azure AD. Depends on what you want to do on your management part, but let's
We had 60 here.
Because I was kind of sitting in it, especially when the something reminding you, hey guys, please, been reminded like still there.
But I know that that's what I was worried about. I knew
Okay. Let's let's get started again. And we'll continue with the last session, last presentation before we get our hands on with Azure. And the last session is, as again mentioned, we made a quick change to the agenda. And now we actually have Joonas talking about managed identities in Azure. And yeah, Joonas, you have the floor. And it's not 45 minutes as some presenters think. According to the agenda, it is 30 minutes as written in there. So you have the floor.
Yes, thank you, Karl. All right, yeah. So, hi everyone. Some of you have seen me before. Some of you have actually even seen this presentation before, like he has, for example. So you might not have known that I will be presenting today, and neither did I until today. So this is quite fun. But this is a presentation that I actually did in a Microsoft Identity Developer training that was held in Espoo at the Microsoft House a while ago. So that was pretty good. So I thought that I would do the same one for you folks. So as just a quick intro, my name is Joonas. I work as a developer and architect here at Azure. I'm one of the Azure MVPs along with Karl and Sakari here. If there's any developers in the room, you know Stack Overflow for sure. So I'm pretty active there. I also have a blog. If you're interested in Azure, like software development side, I blog relatively often. Not as often as I'd like, but I do. There's also a Twitter account if you want to follow me. I don't know why you would. I tweet out blog posts most of the time. So managed identities for Azure resources is the new name for this thing. And it is solving a kind of a specific problem. And that's the problem with secrets. Bless you. So most services actually that you might use, databases, you might use a data storage service, anything, an API. Most of them use some kind of shared secrets or passwords so that your app can use that service, right? So it can authenticate. So the service knows who you are, right? So those things have some issues, mostly because that you have to actually protect those secrets. You have to make sure that they don't fall in the wrong hands. This can involve, for example, keeping those secrets out of code, getting them from elsewhere at runtime, so that you don't publish your secrets to GitHub, which a lot of people do, sadly. Like you can actually search GitHub for commits like remove password, and you'll find like thousands of them, which is sad. You also have to manage them, so you have to keep in mind always like, okay, how many of these do I have? What access do they actually have? Where are they? This kind of stuff that you just kind of have to do. When are they expiring? Because often they expire, and you have to remember to renew them before they do. And yeah, well, you'll find out if you don't. I have some experience with that. You also should remember to rotate them, right? So you should remember to switch them regularly. Like this could be twice a year or once a year or something, or even after like 2 or 3 months, you might want to switch. And this is just in case this secret has fallen into the wrong hands, it will no longer work after you have rotated it. So that's a good practice in general. You also may need to revoke them. So in some cases you might be like, hey, okay, I really don't want this thing to be able to access this anymore, so remove access for this key. You might need to do that kind of stuff. And these kind of secrets often give you like blanket access, like just do anything. Azure Storage is a good example of this because you get 2 keys. And if you have that key, you can do absolutely anything in that storage account. You can create files, you can delete them, you can create queues, do anything, right? So the granularity is huge. And you can't tie this access to a single service, right? Because the secret isn't tied to like a client. It's tied just, to the storage account. So if you're using the same key from two services, yeah, both those services are using it, and it's not really tied to those services. So you can't remove access from one service, for example. If you revoke the key, both services lose access, right? So this is kind of where managed identities comes in, because it's going to come in and solve all of those things. So this is a service that some of you might know as Managed Service Identity. This is what it was called before, MSI as well. That was problematic because Microsoft has other things which are called MSI. Yeah, acronyms are fun. So it has a few main features. It allows for automated service identity creation. Essentially, you just say, I want this identity for this service, and boom, it's there. It does key management and rotation for you. It's completely invisible to you. It will actually rotate keys within itself. It does the whole identity lifecycle management for you. So when you create a managed identity that's actually tied to a service in Azure, if you delete that service, the managed identity is also deleted at the same time. And essentially what this allows is that you can actually call Azure services with 0 credentials. That you don't actually need to store any secrets anywhere in the app, which is kind of cool. And it's available to you for the price of free. If you're not using this, I literally have no idea what to tell you. So there's two types. There's the system-assigned identity, which is tied to a service. For example, an Azure App Service. You can enable this, and an identity will be created that is specific for that app service. Will be deleted when the app service is deleted, right? Then there's also user-assigned identities. These are separate resources that you create in Azure. You can create these however many of you want, and then you can actually assign them to services. So you can share the same identity across services, or a service can actually have multiple identities if you want. So it just allows you that flexibility. The main reason user-assigned identities exist is for virtual machines that run containers. So each container can basically have its own identity that it uses. I prefer system-assigned identities usually, mainly because with the user-assigned identity, you have to take care of deleting that identity if you no longer need it, unlike with system-assigned. And I have a link here that you can check out, which has all the services that actually support managed identities. So not all Azure services support managed identities. A couple that I would like to just highlight is App Service and Virtual Machines, for example. Those support them. And there's a few other ones as well. But do check that. So we don't have any secrets to worry about in our code or configuration if we're using managed identities. Essentially what happens there is that a local endpoint is created within the app service that basically your app can access only. It's a local access only HTTP endpoint that it can call and get access tokens. These access tokens are like temporary keys, right? It's a temporary permit for you to access some service. So yeah, no key rotation to remember. And the greatest one, in my opinion, or one of the great ones, is that you can get more granular access for your apps. It's no longer blanket access. You can actually say in storage that this one service should have a read access to this one blob container. So it's really, really granular. It kind of depends on services, how granular it can be, but it does allow it. It allows for better auditing. So essentially because with the key, the only thing the service knows about the caller is, well, the key, right? They know they used this key. It doesn't tell them who called them actually at all. But with managed identity, the service actually gets a token that identifies the caller. So it actually allows for them to log which service did this thing, unlike with keys. Revocation can be done very quickly and very granularly as well. You can revoke access for one service immediately. So some of the basic principles there is that this is actually generating a service principal, which you can also think of as a service account. It's kind of like a user account, except it's for a service. It creates that in Azure Active Directory, which is connected to your Azure subscription. And then you essentially just need to grant access to this principal to the target service. And this access can be assigned at either the Azure Active Directory level or the service level, and the way that you do that kind of depends on the service. All the services do it a little bit differently, right? It's great. That was sarcasm. So some of the services that do support this method of authentication, so you can use managed identities, include, for example, the Azure Resource Management API. So you can get info on your Azure resources or create resources, do that kind of stuff. You can access Key Vault, which is the secret storage service of Azure, basically. And this actually allows for you to then store those secrets for those services which don't actually support this method of authentication. You can put those secrets in Key Vault and access Key Vault using a managed identity. And then you have, 0 secrets in your app. You can access all of these. And essentially, it's any service that allows for application permissions-based authentication with Azure AD, including your own APIs. So that's a little bit more difficult to set up, but it's possible. Now we get to the really fun part. So by the way, my slides are done. I don't really like slides. So I'm just going to write this URL here. So this demo is a little bit interactive. That is not going to be large enough for you to see. So I'm going to make it a little bit bigger. You can see that this demo app that I've made is a little bit old because it refers to MSI still. So it's a Joonas MSI tests.azurewebsites.net.
Best Zoom ever. Very manual.
Yes, very, very manual. So this is interactive. So if you have a laptop or a phone, it is actually responsive, the UI, which is kind of impressive for a UI that I made.
Quick question.
Yes?
Can I somehow, do the setup of those identities as a description, not, for instance, as manual stuff, because it's always overlooked.
Yes.
Even in cloud parades, sometimes people
yes.
start to do it manually.
Yes. So the question was, can we do this in a more automated way instead of clicking in the portal to do this? Yes. The answer is yes. You can do this with ARM templates, for example, which is one way to describe infrastructure that you want to set up in Azure. And there are other ways. You can use the AZ CLI, for example, to write scripts that do that. So there are multiple ways, essentially. Azure PowerShell also should work. And you can do all those kind of role assignments and all that with scripts, and most of them with ARM templates as well. So yeah, definitely automate it. All right, so here's the website actually, the small web app that I've made. So the point of this web app actually is to just showcase access to a number of different Azure services without using any credentials anywhere in the app. So using purely the managed identity that it has. And I can actually show you one thing first. So if I go here to Azure and open my app service here, I'll show you how to enable this managed identity from the Azure portal. You're going to have to follow me very closely, I know, because this is a little bit difficult. So on the left side, we can find identity. So the icon is very similar to authentication, authorization, but yeah, that's not the correct one, it's identity. Now, then you would come here, click this switch here to on, then click save. You're done. I know that's difficult, but I believe that you can do it. So here also are the user assigned identities, by the way. So if you wanted to assign those identities that you create separately, you can do that here. I don't have any. I only have a system assigned identity. So the first one here is Key Vault, which is one of the cool ones, because what it showcases here in the app is actually using Azure Key Vault as a configuration provider for the app. So it essentially really invisibly uses Azure Key Vault to get configuration data for the app when it starts up. So it essentially gets its configuration from Key Vault. And this value here is actually stored in a secret in Key Vault, which allows for you to, store all those API secrets and stuff if you need those. And then we have Azure Storage. So this is actually reading a file from Azure Storage. And then we have a call to an Azure SQL database, which is also authenticated with this without no passwords, no nothing. Then we also have a Azure Data Lake, which is kind of the same as blob storage, just for a different purpose. So again, reading a file. Then we have a custom API, which is kind of cool. So this is calling an API in a separate app service that I have made. And it's authenticating using the managed identity. So that's kind of cool. So this is just showcasing some of the facts that that API is receiving when it is called by the managed identity. So you can see there's, for example, the app ID, which identifies that identity, basically identifying the caller. But now we get to the fun demos, actually. We have a couple messaging demos. So under Service Bus Queue, there's a send and a listen. So the listening page is actually real time. So if you send a message, it will show up here. So if you press the button, everyone who is on this page is going to receive it real time. And so now, as a kind of a load test, if you could just please click on that send button as many times as you can, and we will see if the app crashes. It's performing pretty well for now. Hasn't crashed yet. I can see that the TV is actually lagging a little bit. Okay, that's really good. Thanks. The fact that it didn't crash is pretty positive. I also have the same thing for an Azure Event Hub, which is really the same demo. It just sends a message to an Event Hub, and that's received here. Now, Event Hubs are a little bit different from Service Bus Queues, with the ability to ingest massive amounts of data, like millions of messages per second. And yeah, you can see the scale is a little bit different for an Event Hub. Yeah, because it's receiving them in batches. So that's pretty cool. And the fact that my app didn't crash yet is pretty positive. Thank you. Thank you for the load test. So in this case, it's actually sending a message to this queue or Event Hub, and the same app, a background service within the same app, is actually receiving it, which is kind of a stupid thing to do, right? Why am I sending a message just so that I can receive it? Well, I mean, it makes for a simpler demo, I suppose, instead of building a third thing there, in addition to the app and the API. Yeah. So all the source code is available for this, by the way. So the main page here has a link to GitHub, to all the source code for this. It also has guidance for you if you want to set this up yourself. There's a bunch of instructions for how to set up, blob storage access and all that. All right. That's actually it for the main content of my presentation. So now I have some time for questions. Any questions? Yes?
I'm just wondering, like, maybe you can tell a little bit more in basic detail. Suppose I have a service that make a REST call to other service. How does it work below the hood? And if I'm calling like the URL, I don't use any keys and whatnot.
Yeah.
How it's handled and how it's achieved that somebody else calling this URL will not get access.
Okay. Yeah. Sure. So
What happens between those two services in the
yeah. So the question was mainly just about like what happens, basically what happens between my app and this service. Okay. Basically, like how the flow works, right? This is where you're going to see my amazing drawing skills. So let's assume, for example, that the service is an API that we've made. Just as an example, honestly, it doesn't matter. So we have an API, and then we have our app, right? So now if I just assume that this is running within app service, and I'll make that as a second box around it. Then what actually happens when you enable that identity is that a service principal will be created in Azure AD, in your Azure AD tenant, your Azure AD instance. And so we'll have a service principal there, which actually has a key registered automatically for you in the background. And that's not something that you need to worry about. That's something the system worries about. It's actually a certificate. It's a key pair, right? It's a public-private key pair. So the public key is actually added here. And then what happens also is that there's going to be this managed identity endpoint within your app service instance. So this endpoint here is not something that outsiders can call. So this can only be called from here. So once you want to access that service, your app is actually making a call, an HTTP call to this endpoint. It's saying that I want an access token for my API. You have to identify what you want the token for. And essentially what managed identity in the background is doing is it's asking for that token from Azure AD.
And this is transparent to me
yes.
when I try to call.
Yes, it's completely opaque to you, like you won't see this. So you get back an access token, and this is then returned to your app, to your code. And now that we have this token, we can then call our API. So you make your call and you attach that access token with the request. It's typically attached as an HTTP header. And then now your API is going to validate that token. Your API is going to do certain validations to that token. And I think that the whole process of token validation, JSON Web Tokens, is a little bit out of scope for this. But trying to summarize it, when this API starts, it's actually loading some metadata from Azure AD. And this metadata includes public keys that Azure AD uses to sign its tokens. And then basically when it receives this access token, this API can by itself verify that this token has indeed been created by your Azure AD, and it can check other things. It hasn't expired, etc., etc. And if it considers it valid, it will return a response to you.
And when API is being called, there is also some sort of other outside box that takes care of this, right?
Here, no. So this is the whole process, actually. So So in order to validate the token, the API doesn't need to make any calls anywhere. It already has everything it needs.
Azure API is
Yeah, but for the process for an Azure API is the same. They do the exact same thing. There's no difference for what they do. But then, of course, then how you do authorization from that point, of course, that depends on your API, that depends on the Azure service, et cetera, et cetera. So with, I can actually show you how it looks like, for example, with Key Vault. So I have my Key Vault here that it's calling. And with Key Vault, you actually have to set up an access policy. So here you can see that my application here has certain access to this Key Vault, and here I can actually verify what access it has. So it has secret management, get, and list. So it has read access, for example. But the way that you set this up depends on the service, right? So for Key Vault, it's like this. And for other services, it's different. I have some blog posts on these, by the way, if you check them out. But thank you. That was a good question. Anything else? Oh, hey, yeah.
So I'm assuming it requires either owner or user's access administrator role for the person enabling the identity.
To enable the identity on a service, I do believe you only need contributor rights on that resource.
The contributor does not have the
Well, you can't give access then, but you can still generate the identity for the resource. Like if I can go and toggle the managed identity to on for an app service, and that'll generate the service principal, but it won't have any access by default to anything. So in order to give that access to, for example, Key Vault, I'm going to need permissions on Key Vault to do that. Like I can't do that otherwise. Okay? Yeah.
Yeah, how do we deal in a situation when we have on-premise Active Directory and we would like to integrate it with Azure AD? How do we manage the identities like those cases?
Yeah, well, on-premises AD and Azure AD integration is, well, it's a little bit out of scope here, and honestly, not even my expertise. But the way that you do that is that there's this program that you install on-premises, and then that will basically synchronize the identities to Azure AD. But managed identity is purely an Azure AD capability and not an on-premises capability.
Do you need any permissions on the Azure AD side?
Yep. No. On Azure AD, you do not require any special role to set up those service principals. So I do have heard that in some larger organizations, they have thousands of service principals as a result. And they're like, okay, so who created this and what it's for? And I have no idea. I have given some feedback to the Azure team responsible on that.
Well, isn't there the option that you can disable users creating those in your Azure AD?
Well, yeah, so you can prevent users from generating apps or registering apps in Azure AD. I don't think it applies to this, but or have you tried this actually? I mean, I could be wrong. Yeah, that's an interesting question. That because in Azure AD there's a toggle that basically says normal users can't register apps, right? So if that's on, would it be possible to still create these? And the answer is, I think it should still be possible, but honestly, I'm not 100% sure.
In that sense, an app registration is pretty much
because the thing is, it's like you are not technically creating the service principal. It's the Azure's resource provider there in the background which is doing it. So it might not be acting on your behalf actually for that. Not sure, honestly. Okay, more questions? Or do you want to get to the labs? Okay. Then let's go ahead to those. Thank you.